So, tutorial sheet 2, question 2. The question states here, carrier wave represented by 10 cos 2 pi times 10 to the power of 6t is amplitude modulated by a baseband signal represented by 3 cos of 2 pi times 10 to the power of 3 times t volts. And we have to calculate a whole range of values from that. So first thing we need to do is actually extract the information that's important to us. So we're given that the carrier voltage as a function of time is equal to 10 cos 2 pi times 10 to the 6t volts. And that's our message. Voltage Vm of t is equal to 3 cos 2 pi 10 to the 3 t volts. So that's the information that we're given to us. Question, or part A, asks us to work out the modulation index. And that's very simple. What we need to recall is that the modulation index for a double sideband AM system is very simply the peak value of Vm over Vc. And we can see that from here. So the peak value of Vm is 3 volts divided by 10 is equal to 0.3. So that's how we work out the modulation index for that. Part B. Well, that asks us to work out the upper and lower sideband frequencies. And for this we can recall what the frequency spectrum of the signal looks like. So if I plot the graph of the amplitude of the signal, what we're going to get is a carrier frequency and then 2 sidebands. And the first sideband, or the upper sideband, is at Fc plus Fm, and the lower sideband is at Fc minus Fm. So we need to use these two equations. So we say the upper sideband is equal to Fc plus Fm. So how do we work out what Fc and Fm are? Well, we can work that out from the information that we're given here. So that what we're given is 2 pi times 10 to the 6. So what we're actually given is that omega c is equal to 2 pi Fc, which is equal to 2 pi times 10 to the 6. In other words, Fc is equal to 10 to the 6 Hertz. And similarly, omega m is equal to 2 pi Fm is equal to 2 pi times 10 to the 3. So Fm is equal to 10 to the 3 Hertz. So in this case, the upper frequency is 10 to the 6 plus 10 to the 3. Which is equal to 1.001 megahertz. And the lower sideband frequency is Fc minus Fm, which is 10 to the 6 minus 10 to the 3, which is equal to 0.999 megahertz. Okay, part C. Well, that asks us to work out what the amplitude of the sidebands are. And for this we can either recall this from the graph, and which is plotted in the notes, or we can recall this from the standard form of an AM signal. So if we do that, we have this form here. So we've got 1 plus m. In this case we've got cos, and we get m of t to cos omega c of t. That's the standard form of the equation. If we multiply that out, we get Vc cos omega c of t plus mvc cos omega m of t cos omega c of t, and using a trigonometric identity, in other words, cos A times cos B is equal to a half cos A plus B plus cos A minus B. Essentially what we've got here, if we rewrite VAM, we've got that the sideband amplitude is going to be MVC over 2. So the amplitude of the sideband is MVC over 2. And if we work out what that is, we get 1.5 volts by using the value of M that we've worked out previously, which is 0.3 times 10 divided by 2. Part D, well, that asks us for the fraction of power contained in the sidebands. So here we need to recall the amount of power, or the equation for the power in an AM system. So the total power is equal to PC, 1 plus m squared over 2. So what we have here is this one here, that's the element from the carrier alone, and this is the element from the sidebands. So if we want to work out what the fraction of the power contained in the sidebands is, so the fraction, well, that's going to be equal to power in the sidebands, which is PC m squared over 2, divided by the total power, which is PC 1 plus m squared over 2. Of course, the PC's cancel, leaving you with a relatively simple equation to rearrange. And if you work that out, and you work that out in a percentage, you get 4.3%.